Now we're going to find the line that represents the intersection between two planes. That is, let's say we have this plane and this plane. They intersect exactly in one line. This line. We are going to find the equation of that line given the equations of the planes. So first, between the line that represents the intersection between the planes x plus y plus c equals 1 and x minus 2y plus 3c equals 1. Then between the planes, 3x minus 6y minus 2c equals 15 and 2x plus y minus 2c equals 5. If you think you can do it, stop the video now and next continue to see if we have the same result. Alright, first, yes, we have this plane and this plane that are intersecting, and we have a line. So that line that we're going to find lives in each one of the planes. So that means that that line is orthogonal to both each normal vector of each plane. So we have a normal vector for this plane, a normal vector for this plane, and that normal vectors are perpendicular to this line. So again, we need the cross product because we have that the normal vector of this plane, the normal vector of this plane, both are perpendicular between them. Let's say this for this plane and I don't remember how I put them. Let's say like this. So this is the normal vector for this plane. This is the normal vector for this plane. So we have this. And we have that the line of intersection is perpendicular. That is this line. And it's exactly that. We have this plane, this plane, this plane, like this. The line of intersection is this. Yes, no, I put it, or I don't know how I put it. Like this, like this. So here is this vector. The other is like here, so it's this vector, because we have, oh, what's difficult to do. We have, let's say, this plane, and so the line of intersection is just along this line. So it's like this. So we need to find this line. That is the other vector perpendicular. So we need to use the cross product, product between the normal vectors of each plane. So the normal vector of this plane is v1 equals 1i plus 1j plus c, plus 1k, and v2, the normal vector of the second plane, is I minus 2j plus 3k. Alright, so now let's cross these vectors. So we have I, j, k, 1, 1, 1, 1, minus 2, 3. For me, it's easier to put the first two columns. So it's I, 1, 1, j, 1, minus 2. And I realized that in the other video, I think that at least 2 mistakes that I didn't correct in the video, but they were just arithmetical mistakes. So hopefully you have the idea of the concept. Alright. So here, the cross product is this times this. I will just put it like this, or A is this times this times this. So I have 1 times 3 is 3i plus j minus 2k all of this minus all of this, that would be j1 that's j, then j1 3j, then I1 minus 2i, and then plus k. Alright, so we have 3i plus 5 plus 2i is 5i, j minus 3j is minus 2j, and minus 2k minus k is minus 3k. Yes? Let me just check it. Yeah, alright, I think so. Alright. So this is the vector that is parallel, let's say, to the line of intersection. Now, yes, alright, we have this. Let's say we have a vector that is parallel. We can have the direction only if you want. That would be just divide this by its magnitude. That would be just the direction. The important here is that we have the let's say the vector that is parallel to the line that we are looking for. Now, in order to have the line, is as the previous example, when we have a point and the parallel vector. So, which point do we have? Let's say let's take a point that is in the line. That is, just for convenience, let's say when c equals 0, this would be x plus y equals 1, and here would be x minus 2y equals 1. So I have x equals 1 minus y, and x equals 1 minus 2, 2y plus 1. So I have 1 minus y is equal to 2y plus 1. I have minus 3y is equal to 0. So y is equal to 0, and x is equal to 1. Alright, so the point that I'm taking is p equals to 1, 0, 0. That point that lies in the line which is parallel to this vector. So it's exactly the now we have exactly the problem as we began when we derive the equation of the line. We began with a point that was x naught, y naught, z naught, and the vector that's parallel. Alright, so we saw that the equation of the line was x minus x naught divided by, well, if you want, I could put first I minus equals y minus y naught divided by b equals c minus c naught divided by c. This was equals, I call the constant m. Usually the books call it t. But here we have our equation. We also saw that I think that in the next video, after the equation of the line, we saw that we could see it like the line is the intersection between this plane and this plane. Alright, so now we have x minus 1 divided by 5 plus y minus 0 divided by minus 2, so I will put minus 2, minus c, that's 0 divided by 3, equals. So I have x minus 1 divided by 5 equals minus y divided by 2 equals c divided by equals minus c divided by 3. These are the symmetric equations for the line. Remember, these are the symmetric equations for the line. So this is the general, this is this example. If you want to now put it in the parametric equations of the line, that is when you have, remember that you have m equals x minus x2, x naught equals a, so you can put m times a equals x minus x naught under this. So here you have, let's put m, so you can do 5m is equal to x minus 1, so x is equal to 5m plus 1. This would be m equals to minus y over 2, so you have y is equal to minus 2m, and this you have equals to n, so you have c equals to minus 3m. So this is the vector parallel, or is a vector parallel to the line of intersection between these two planes. These are the symmetrical equations of the line, and these are the parametric equations of the line for this plane. Now let's do the same for the next two planes. Alright, again, now we want to find the line that intersects, or the line that is the intersection between this plane and this plane. So we are looking at a vector that is parallel to that line, that is orthogonal to the normal vectors of each one. So let's do the cross product. First, B1 is 3i minus 6j minus 2k, and B2 is 2i plus j minus 2k. Alright, now the product, the cross product, I, j, k, 3 minus 6 minus 2, 2, 1 minus 2. I, 3, 2, j, minus 6, 1. Alright, so first this is 12i minus 4j plus 3k minus minus 6j minus 2i and minus 12k. I hope not to be doing another silly mistake. So 12i plus 12i, that is, sorry, 12i plus 2i is 14i. Next, minus 4j plus 6j is 2j, 3k plus 12k is 15k. So if I haven't done any silly mistake, this is the vector that is parallel to the line of intersection between these two planes. So now the point, let's pick any point that is in the line. For convenience, we say c equals 0. So if c equals 0, this equation would be 3x minus 6y equals 15, and this would be 2x plus y equals 5. So I have 3x, and let's divide everything by 3. So we have 2x minus 3y equals 5. So 2x is equal to 3y plus 5. X is 3y plus 5 divided by 2. And here we have x, 2x is equal to, this is x minus 3y equals 5. So here's just 3y plus 5. Sorry. Yes. Next, this was x is equal to 5 minus y divided by 2. So we have 3y plus 5 equals 5 minus y over 2. This is 6y plus 10 equals 5 minus y. So, yeah. So we have 15. I think that I did a mistake of this sign. Five plus 3y, 2x plus y, so here's 5 minus y divided by 2, 3y plus 5, so I have 6y plus 10. Okay, so this is 6y plus 10 equals 5 minus y. I already realized what happened. Here is a 2. Okay. So I have 2y plus 5 equals 5 minus y over 2, and so this becomes 4y plus 10 is equal to 5 minus y. Now 5y is equal to minus 5, y is equal to minus 1. Really, I'm sorry for that. We have y, now x. X is equal to minus 2 plus 5, 3. Or you could do it here. 5 plus 1, 6 divided by 2, 3. Alright, so our point is 3, minus 1, 0. And we have this vector that is parallel to the line. So, again, would be now x minus 3 divided by 14 is equal to y minus 1, so plus 1, divided by 2 is equal to c minus 0 divided by 15. Again, these are the symmetrical equations or the symmetric equations for the line. Now the parametric, if you wish, here let's put n, would be 14n equals x minus 3. So x is equal to 14n plus 3. Here is 2n is equal to y plus 1. Y is equal to minus 2n plus 1. Yeah. So sorry, 2n minus 1. And c is equal to 15. And these are the parametric equations of the line.